Hello, Vectors Part 2 by Anand Mohandas. That's me. So, why we learn more about vectors? Let's see. In physics, motion is typically described in terms of displacement, velocity, speed, acceleration. So lots and lots of motions in physics. We already know that a moving object can be represented using vectors. I have drawn a picture of some vectors going up, going down, going sideways. So learning more about vectors can help understand or describe the motion of objects. As you can see, we can just replace the motion with a vector. And generally, this is basically to solve physics problems. Don't get scared hearing the words physics problems. Let's just focus on learning more about vectors. Let's begin. Scalars, vectors. What's a scalar? What's a vector? Now, any measurement that comes up with a single number is a scalar quantity. So 5 km is a scalar, 80 meter is a scalar, 200 meter is a scalar, 1000 meter is a scalar, 25 years is a scalar, 50 gram is a scalar. Now, the numerical value with unit is called magnitude. So, scalar have a magnitude. You can see the numerical value 80 and unit meter. So, scalar have a magnitude. Now, vectors. Vector is different from scalar. Vectors have directions. Let's say direction. Now, you have 10 km north is a vector quantity. 500 meter southwest is a vector. Force is a vector. Velocity is. You can see 10 km is a magnitude. North is another direction. So vectors have magnitude and direction. So simply scalar is like this. It can be represented this way, 5 meter and vector 5 meter north. You can see the 5 meter north pointed towards, so have some direction. So it's a vector. Now magnitude, as you know, already I said magnitude is like has a unit and has got a numerical value. That's a magnitude. It's also the absolute value of a vector, magnitude. For example, you have a vector 5 meter going in one direction and another vector going in the opposite direction. So the distance is the same, but the direction is opposite. But if I ask what's the absolute value of this vector, I can say both the absolute value is 5 only. One vector is going in one direction, the other vector is opposite direction, but their absolute value is the same. So absolute value of a vector is its magnitude and is a scalar. And minus sign that denotes the opposite direction from the plane of reference. So absolute value of minus 5 is 5, absolute value of 5 is 5. You just ignore the direction. So when we ignore the direction, it means it's a scalar. Now let's see some vector definitions. Zero vector. Now zero vector, magnitude is 0, direction is arbitrary. That means, there is a vector, magnitude 0 means it's some point and it's not moving, it's not going anywhere, it's standing right at the point. So you cannot say which direction it's going. It's 0. Vector A is 0, it's called a zero vector. Zero vector is also called a null vector. Now equal vectors. So two vectors going in the same direction and the same magnitude, they are equal. So from the diagram you can see 10 meter, A vector A going 10 meter some direction and vector B going in some direction. Both are equal, same direction and same length, so they are equal. Now negative vector means same magnitude but opposite direction. For example, something travels from A to B and something else travels from B to A. So distance is same 10 meter but the direction is opposite. So AB vector is equal to minus BA. That is negative vector. Now, as I already said, equal vectors, the magnitude and direction both the same. So how do we represent in a graph? It need not be on the same, always like on the x plane or just on the y plane. Even two vectors need to be on the same plane. That's the idea. So in the diagram, what you see is equal vectors. U vector, vector U and vector V are equal. This is how we can represent it in a Cartesian plan. Now let's see addition and subtraction. Addition and subtraction from the diagram you can see it's very simple. If vectors are in the same direction, we can simply add their magnitude. For example, that 3 meter plus 2 meter gives you 5 meter, the resultant vector. So in the second example, you can see 2 meter going in the opposite direction plus 6 meter going in the other direction. Resultant vector is 4 meter. So we are simply adding because it's on the same plane. Now what if the two vectors are not in the same plane? They both start from the same point but they're not in the same plane. One is going in one direction, other one is going in other direction. What we do is just add the coordinates x and y. So we have the vector v, the coordinates are 2 and 3 and u is 2 and 3 and v is 3 and 1. So we just add the x coordinates and we just add the y coordinates, get the result. So w vector is equal to 5, 4. Now you can see the resultant vector is not in the same way. One is the vector u is going in one direction, v is going in one direction and w is going in another direction. Interesting. Now there is something called scalar multiplication. 3 vectors here I am representing equal vectors. A is equal to another A plus and you can add these 3 or you can simply say 3 into vector and 3 is a scalar, so it's called scalar multiplication. You can see very easily understand from the diagram. So when you represent it in a Cartesian plane, here you can see A going in one direction, same direction, 2A, another vector. So scalar is multiplied by 2, scalar multiplication. Now there is another vector, the same size, same length of A, but going in the opposite direction. This is minus A. Now we have completed part 2 and we'll continue part 3. We'll see more of vectors in part 3. Thank you for watching. Excuse my English because I am doing it in one take and I am not an expert in this. But I hope you understood today's class. Thank you.